Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day. And today's problem is prime list, which is a medium level problem. So the problem statement says that we have been given the head of the linked list. So basically we have been given a linked list and we have to replace all the values of the nodes with the nearest prime number. So the nearest prime number means any prime number which is nearest to it, and it can be either to the left or either to the right. It doesn't matter. It just has to be like nearer to it. And if they are at an equal distance, we have to choose the smallest one. That is the one to the left of it, right? So we have been given some linked list like this. So for example, let us take this example 2, 6, 10. So if I have three numbers 2, 6 and 10, I have to replace this particular number with the with a prime number. So it is already prime number, so there will be no change to it. For 6, I will have to see what are the prime numbers near it. So for example, 5 is a prime number as well as 7 is a prime number, and 6 just lies between them, and the distance of both of them is 1. So the distance from 5 to 6 is 1 and the distance of 6 to 7 is 1. So I have to take the smaller one, that is the one to the left of it. So in the second position, my value would be 5. Now as for 10, the last prime number was 7, and then 8 is not a prime number, 9 is not a prime number, then 11 is a prime number. So in this case, 7 lies here, 11 lies here, and the distance of these two is 3. The distance of these two is 1. So obviously 1 is smaller, and I'll have to take 11 here. So my final linked list would be 2, 5 and 11, and I have to return the head of this linked list, right? So as you can see, 2, 5 and 11 is the answer. So how can we approach this particular question? Now one way to do it is like having all the prime numbers beforehand, and it would be a lot simpler to find these numbers in that particular list. So for example, if I have a list of prime numbers, let's say it is called primes. So I have a list, or by list means any data structure in which you have all the elements. It can be a vector, it can be an array or anything. So I have a list called primes, and it has all the prime numbers. Let's say starting from 2, then 3 is a prime number, 5 is a prime number, 7, 8, 9, 10 are not prime numbers, then 11, 12 and 13, then 14, 15, 17. For example, let us take these numbers, right? Now if you have to find a prime number nearest to let's say 12, right? So what you can see is, where does 12 lies in this particular list? So I can clearly see that 12 lies between 11 and 13. Then I can compare its distance with the element to the left of it and to the element of the right of it. And if you have observed it till now, that this is a sorted list, so you can easily apply binary search on it, right? So whenever you have 12, you can use binary search to find the position of 12 in this particular list. And if you use STL, like if you use lower bound or upper bound, both of them, since all the elements are unique, so both of them would give the same result. So if I use lower bound or upper bound, it will give me the position of the element which is just greater than 12. So in this case, it would give me the position of 13. Then from the position of 13, I can get the position of 11, right? So with the help of like these STL functions for binary search, I can easily find the position of the elements that are to the right of my element and that are to the left of my element. So once I get these three elements, 11, 12 and 13. So 12 was my input, like the node of my linked list, and I got 13, the position of 13 using binary search, and I got the position of 11 using binary search. So now I know what is the element to the right of 12 and what is the element to the left of 12. Now I can compare the distance of both of these two places, and if the distance of the left side is less than or equal to the distance of the right side. Why less than or equal to? Because the question says that if the distances are equal, we have to take the smaller number, right? So if this distance is less than or equal to the distance of the right number, then we can take this particular number as our node value, right? Otherwise we have to take the second number as the node value, right? Now there are like two important cases that we need to consider. What if the element is the leftmost element, and what if the element is the rightmost element? Now I'll explain what I mean by leftmost and rightmost. For example, if I take 1, right? Now 1 is smaller than all the other prime numbers in this list. right? So there will never be a left element to it. So we'll have to take care of this particular case. So let us assume on the right hand side we have like the greatest prime number 101. So if some number is like we have been given the input as 105, so obviously there would be no number to the right of it, and we'll have to only have to consider the left number, right? So these are the two cases that you have to consider, especially that when the number is the leftmost number and when the number is the rightmost number. Now the next question is, how do we get this primes list? How do we get the list of all the prime numbers? For this, you can use an efficient algorithm like sieve of Eratosthenes, and using the sieve, we will get what are the prime numbers between any range. For example, 1 to 10 raised to the power 5, and if we get the prime numbers in this range easily, then we can store all those prime numbers in this particular list. So this is exactly what I have done in the code. Let me just show you the code now. So initially, so this is my solution function. This is the original functions that we got in the template code. Now I've created a vector of integers called primes, right? So this will store all the prime numbers. Now I've called the C function, which will fill this particular vector for me. If I go to my C functions, as you can see, like I've taken the maximum limit as 10 raised to the power 5. Now the reason why I've taken this 10 raised to the power 5 is like very interesting. The question initially mentioned that the value of the node is up to 10 raised to the power 4, and since this was 10 raised to the power 4, I also took it around 10 raised to the power 4. But like I got wrong answer because of it, and when I checked the input file, there was a number that was greater than 10 raised to the power 4. So generally you won't get any such differences. Like the question mentions it should be less than equal to 10 raised to the power 4, but the input file had some numbers greater than 10 raised to the power 4. So normally the case would be like this, but it is better to be on the safe side. So I just later I took like 10 raised to the power 5, and later I got accepted, right? So now I've created a vector of a boolean which will store whether my element at the ith position is prime or not, and I initialize all of them with true. I mark 0 and 1 as false because they are not prime. I just do normal sieve thing like starting from 2 and all those things and marking all the non-prime numbers false, right? So at the end what I just do is I just make a for loop from 0 to less than max, and if I check if the current number is a prime number, then I just push back into my prime vector. So since I have passed my prime vector as my address, so I don't need to return anything. It will automatically get saved because this is like I'm passing the reference of my vector primes. Similarly, the next thing I call is my traverse vector. So this will traverse function which will traverse through all the values in my linked list. So for the first thing is what I check if the current node is a null node or null pointer. I just return from here because I have reached the end of the linked list, right? The next thing what I do is I just store the value of the current node in a variable called val, and I calculate the position of the position. So this particular function lower bound will give me the position of the element that is just greater than my current value, greater than or equal to, right? So here I get the position. I create three variables, left, right, and new value. So left will store the distance of the left element, right will store the distance of the right element, and new value will obviously store the new value that I have to update. Now I can easily find the distance of the right element by doing primes of p minus val, and then I can find like if there is a left element, how do I know whether exists a left element or not? For that, for the left element to exist, the value of p should be greater than 0. So for example, in this case, in this particular case, when my input was 1 and my first element in the array was 2, so when I do a lower bound or call the lower bound or upper bound function, the position that I'll get is 0, right? So this means that the input value is smaller than all the other values in the primes vector, right? So for this condition to not happen, the position of p or the value of p should be greater than 0. So that is why I've written if p. So this if p is equals to 0, then this condition would be false, or you can also write it as like this: if p is greater than 0, both of these are equivalent, right? So once I have done this, I have calculated both the left and right positions. Then here in this particular condition, I check whether p is equals to primes of size. So this is the condition when input is rightmost element, right? Or the input is greater than all the other values. Similarly, so if the input is greater than all the other values, then the new values will be equal to the last prime number in my list, right? So for example, here my input value was 105, right? And the last prime number was 101. So this is the number that I have to replace it with because I have no numbers to the right of it, right? So this would be the nearest number that I can replace 105 with. So I have all so I will obviously take the last element that is present in my list, right? So this is for the rightmost element. Now for this is the else if condition where I'm checking p. So this is also the same thing. I can also write it as if p is greater than 0. So this is the same condition where I have to check input is in the middle, right? So if p is greater than 0, then obviously input lies between somewhere between the leftmost and the rightmost element, and like it will be in the middle of two numbers. So I can now check whether the left value is less than equal to the right value. Then I can replace new value with the left value. Otherwise I can replace the new value with the right value, right? So this is when the input is in the middle, and the third case is when the input is leftmost, right? So in this case I have no option. I just have to like update a new value with primes of p, that is the right value or the value at the 0th position, right? So now at the end, what I do after all this processing is done, I just update the current value with new value, and I call the traverse function again with the value of next node, right? So this will continue, keep on going until the linked list ends and we reach the null pointer, and from there the whole it will like it will trace back and the function will end. So after we get back to the prime list function, our main function which was initially called, I can just return the head pointer and all of my linked list would be updated. So I hope you guys were able to understand this particular solution, and as usual the solution will also be provided in the description. You can find the code there, and if you guys were able to understand, then you can subscribe to this channel because I'll be uploading like similar videos on my channel. I'll be uploading video solutions as well as the contest solutions if possible. So till the next video drops, keep coding, stay safe, bye bye.